Section 6.1 is a brief review of power series. We're going to be looking at solving complete problems in Section 6.2, but for right now I want to concentrate on one specific part, adding two power series together. We're going to be doing this every single problem when we get to 6.2, so we want to make sure we understand how to do this. Now, when we combine two power series together, there's two steps to the process. The first step we're going to have to do is match the powers on the variable. We're going to do this by a quick substitution. The second thing needs to be done is to have the two summations start at the same value, and this will involve stripping terms off of the power series. So we're going to look at this specific problem. We want to combine these two power series together. Notice the two things are not matching. The powers on the x are definitely not the same, and where the two power series start are not the same as well. We need to fix both of those issues first before we can continue. So, matching the powers. I want to get both of those to look like x to the j. So what we're going to do is make a substitution. Whatever we see for a power of x, we're going to substitute that formula as j. But we're going to do that separately, a substitution on each individual power series, not one overall substitution. So for the first power series, we're going to call j n minus 1. Now if I let j equal n minus 1, then n is going to equal j plus 1. So we're going to make those substitutions throughout this first series only. It will also change where that series starts at. It originally starts at n equals 1, but if j is equal to n minus 1, the new one will start at 0. So that first summation is going to turn into this. Now we're going to do the same process on the second power series, but with a different substitution because it's x to the n plus 1. So we're going to call j n plus 1, and again, follow through what happens. If j is n plus 1, then n equals j minus 1, and we'll also fix where the series starts. Again, notice, we're not doing anything to that first power series. This is only affecting the second power series. Now, when we make that substitution, again, notice those powers are now matching. They're both x to the j. So step 1 is complete. Our second step is to match the indices. That is where the power series are starting at. Again, notice they're not the same. Our first power series starts at 0, but the second one starts at 1. They need to start at the same location. So what we're going to do is look at the power series that's starting earlier. This is the first one on the left that starts at 0. We're going to strip off terms until they match. All we have to do is strip off the j equals 0 term. If we write that one off to the side, then the power series will start at 1. So they will match. Now, stripping that off involves plugging in j equals 0. If I plug j equals 0 into that first power series, what I'll be left with is c1 x to the 0, or just c1. So this is what we have now. Again, we still have those two power series. That c1 plus power series is our first original power series, and then we have our second power series. But now the powers on x are matching. They're both x to the j, and they're both starting at the same location, j equals 1. So those two power series can now be combined together into one big power series. Notice that c1 term we stripped off is not part of this. It's off to the side, but I have one power series remaining. Summation j equals 1 to infinity. I combine those coefficients together into 1, and then all times x to the j. And we've done it. So our homework for 6.1 is really practicing this one critical step. So you want to make sure you're okay with it. It will take some time to master, but you want to be sure to ask questions about this, because when we get to 6.2, this is going to be the first step we do in every single problem. So we want to make sure you're good with it. Post on the discussion board if you have any questions or comments.